Consider this node here. This node has 3 more nodes here. So these 3 are called as child nodes. What is binary tree? Binary tree is a tree which has each node has at most 2 descendants. The topmost node is the root node, and from there all operations start from the root node, and it doesn't have any parent. Dear students, welcome to Computer Science classes. I am Ravi Kumar Kyar, lecturer in Computer Science, Vidhyaashram PU College, Temple of Excellence, Mysuru. Students, let us start our session with the topics non-linear data structure, trees and graphs. In our previous session, we have learned about a linear data structure. Now let us see what is non-linear data structure, and trees and graphs are example for non-linear data structure. Now let us see the definition of this. A non-linear data structure is a data structure in which a data item is connected to several other data items so that a given data item has possibility to reach one or more data items. So just look at the definition of non-linear data structure. It is data items are connected to several other data items. Means here data items are not arranged in a definite order. And if you see the definition of linear data structure, where the data items are connected or arranged in a sequence or a continuous sequence. So that is linear data structure. But in nonlinear data structure, data items are not arranged in a definite order. So that is the meaning of it has the possibility to reach one or more data items. Now the data items in a nonlinear data structure represent hierarchical relationship. Each data item is called a node. Here in nonlinear data structure, we use the word node. Node is nothing but a data item. And example for nonlinear data structures are graphs and trees. These two are data structures. Example for nonlinear data structure. Now let us move on to the next slide. Now it is trees. A tree is a data structure consisting of nodes organized as a hierarchy. See, what is the meaning of the word hierarchy? Now look at the definition here. In this one, see this from here, these two nodes are connected to this, and this node is connected to this node. So this is a hierarchy. And if you consider this side here, see from this is connected to this, and these two are connected to this, and this is connected to this. So these are nothing but the organized as a hierarchy. Now if you look at the diagram here, these are called nodes. One here, from here, this, here, and all these are nodes of a data structure. And here you can see the definition of different terms here we are using in trees here. This is ancestors, descendants, and there are different levels, level 3, level 2 and level 1, and these are the leaf nodes. All these are we are going to learn the definition now. Now a node is a structure which may contain a value, a condition, or represent a separate data structure which could be a tree of its own. So here what we have seen in the previous slide, these are the nodes. See, these nodes may contain a data item. It is nothing but any values. So it may contain a value or a condition, or it can be a separate data structure also. Each node in a tree has 0 or more child nodes which are below it in the tree. By convention, trees are drawn growing downwards. See, if you look at this diagram here, these are the nodes where we can store values. So here, these are the nodes, and as per the previous definition here, each node has a 0 or more child nodes. In this example, you consider this node here. This node has 3 more nodes here. So these 3 are called as child nodes. So for these three nodes, this becomes a parent node. So that is the definition of the statement. Second statement, each node has a 0 or more child nodes. And a node that has a child is called the parent node and or ancestor node or superior node. A node has at most one parent. Yes, if you look into this diagram here, this is a node and this has three nodes. So this is called a parent node and these are called child nodes. And here you can see the ancestor node. What is the ancestor node? Ancestor nodes are nothing but the previous node, and descendant node. Descendant nodes are nothing but child, and this node is an ancestor node. So this ancestor node is also known as a parent node or superior node. So these are the different terminologies. And the last node where it doesn't have no more nodes here, this is called leaf node. This is a leaf node, means this is the last data item or last node of a tree. And in this example, these two are the leaf node where these two don't have any of the nodes here. So for these two, this is the parent node, and for this will be the parent node. So parent node is also known as ancestor node, and for this parent, we have these two childs. These are called as descendant nodes. Next definition is a height of a node. Next definition is height. The height of a node is the length of the longest downward path to a leaf from that node. The height of the root is the height of the tree. Now let us see what is the definition of height. It is length of the longest downward path to a leaf from the node. Look at this example here. Now in this example, root is the first node, and here, for example, the length of this node. In this one, what is the height or what is the length of this? So for this is the parent node and this is the parent node. This is the parent node for this and this is the root. So from here to here, there are 4 nodes. So the height of the tree is 4. That is the definition of height. Suppose if you consider this node. Now what would be the height of the tree? From starting here, from here, this is 1 and 2. The height of this node is 2. Now, what is the height of the entire data structure tree? It is from the last node to till the root node. That is the height of the entire tree data structure. So, that is the definition of height. Next one is the depth of a node is the length of the path to its root. Its root path. The depth is nothing but the length of the path to its root. For example, you consider this example here. Now, the definition of depth. For example, the depth of this node is to the root node. So, from here to here, the root is 1, the depth is 1. So, that is the definition of depth. Next one is the topmost node is in a tree is called the root node. Is called the root node. Being the topmost node, the root node will not have any parent node, and it is the node at which the operations on the tree commonly begins, and all other nodes can be reached from it by following edges or links. So the topmost node is the root node, and from there all operations start from the root node, and it doesn't have any parent. If you look at the example now, this is the root node, this is the topmost node of a tree, and these nodes don't have any parents, so it is the root node, and any operation must start from the root node. Now let us move on to next slide. Here, the internal node or inner node is any node of a tree that has child nodes and is thus not a leaf node. Now let us see next definition. Now a subtree. A subtree of a tree T is a tree consisting of node in a tree T and all of its descendants in it. For example, look at the diagram here. What is a subtree? A subtree is a node and it has so many, or it can have number of nodes, number of child nodes. So in this example, consider this one here and these three nodes. And this is a subtree because these two are the child node and this is the parent node. So this forms a subtree. So a subtree, it must have ancestor as well as descendant node. That is the definition of subtree. Now let us see the example of tree. Here, binary tree. Binary tree, it is the simplest form of tree. Here, binary tree is an example for non-linear data structure under tree. The simplest form of tree is a binary tree. A binary tree is a tree in which each node has at most two descendants. A node can have just one, but it cannot have more than two. So what is binary tree? Binary tree is a tree which has each node has at most two descendants. At most two descendants. Now look at the example here. In this example, there is an example of binary tree. This is the root and these are nodes. And this is a parent node for this and this is child node for this. So here 10 and for example data item 10 and 5 are the child nodes of this root. This is parent tree and this parent node. And here if you consider this node has only two nodes. So it is an example for binary tree. So as per the definition, each node has at most two descendants. And here in this example, you take example here 5, it has only two descendants. It is an example for binary tree. And a binary tree consists of a node. It is called the root node. For example, this is the root node. And left and right subtrees. And this is the root node and these two are the nodes and these two are the child nodes and this is the parent node and again this is a parent node and these two are child nodes. So this is a node and left and right subtrees. This is an example for tree and this is an example for one more tree. And this is binary tree where it has at most two descendants. Now both the subtrees are themselves a binary tree. These are the subtrees are binary tree. The importance of binary tree is that it can create a data structure that mimics yes or no decision making process. And the importance of binary tree is used to create a data structure where decisions can be taken with either yes or no. This is a binary tree. Now let us see other few different terminologies here. And here root node. Node at the top of a tree is called the root node. And this is already we have learned definition with respect to tree data structure and this is with respect to binary tree. Binary tree is an example for a tree data structure. So here root node, as you know in this example, this is the root node and from which all operations are starts. And the root node may not exist if there is a null tree. Leaf node. What is a leaf node? Node at the bottom of a tree or the farthest from the root. Leaf node have no children. In this example, if you consider 3 is your leaf node because it doesn't have any children. So this is the parent. 5 is the parent for 3 and 6 data items. So here 3, 6, 8 and 15 are leaf nodes because they don't have child node. And complete tree, the tree in which each leaf is at the same distance from the root. All the nodes have maximum number of subtrees. So what is a complete tree? In which each leaf is at the same distance from the root. In this example, this says there are two descendants for this, and here there are two. It is an example for a complete tree. Now height, number of nodes which must be traversed from the root to reach a leaf of a tree. This is what you have seen, the same definition with respect to tree data structure. The height is the maximum number of nodes to reach from top till leaf node. That is the definition of height. Now let us move on to the next slide, that is graphs. A graph is a non-linear data structure. So it is an example for non-linear data structure. So a graph is a set of vertices and edges and which connects them. A graph is a collection of nodes called vertices, and here in this example, A, D, E, C, B are called nodes. They are called vertices, and the connection between them are called edges. So here you can see this arrow mark. This arrow marks are called edges. They are going to connect different nodes or vertices. So graph is a non-linear data structure. Now, when the edges in a graph have a direction, the graph is called directed graph or digraph. Another name of this is digraph, and the edges are called directed edges or arcs. So in this example, it has a direction. It is an example for directed graph or digraph, and these edges are called directed edges or arcs. Now, a vertex, that is the end point of an edge, is called a neighbor of the vertex. Here, a vertex, that is the end point of an edge, is called neighbor of the edge, that is its starting point. The first vertex is said to be adjacent to the second. Here, look at the example now. The following diagram shows a graph with 5 vertices. Here, vertices are nothing but the nodes. In this example, there are 5 vertices A, B, C, D, and E. And edges are nothing but the connectors, or we are connecting different data items through edges. And here with the 5 vertices and 7 edges. 7 edges in the sense 1, 2, 3, 4, 5, and these two are bidirectional. So there are 2 edges here, and this is also bidirectional. It has, so we have to count as 2 edges here. So the edges between A and D, here, this the edges between A and D, and B and C. And B and C are called pairs that makes bidirectional connections. So we have to take it as 2. So here is a bidirection. There are 2 directions. So there are 2 edges here. So here there are 2 edges, and here there are 2 edges. And it represents bidirectional, and represented here by a double-headed arrow. Double-headed arrow stands for bidirectional. And here in this example, only unidirectional. So this is 1 edge here, and this is 1, and this is 1. So totally in this example, there are 7 edges here. So this is an example for a graph with 7 edges and 5 vertices. Students, in this session, we have discussed about a non-linear data structure with respect to trees and graphs. We will continue our discussion in our next session. Thank you very much.